The space surrounding you is a physical, measurable material, one that Earth physically drags along with it as it rotates. In 2004, NASA launched the Gravity Probe B satellite to test the integrity of that material. Its gyroscopes were designed to measure whether Earth's rotation was physically pulling on the vacuum of space. This lens-Thurring effect was first calculated in 1918. The math suggested that the massive weight and spin of a planet would create friction against the surrounding universe, physically twisting the space-time continuum. The probe's data proved the prediction. Space-time behaves like a dense fluid that bends, warps, and flows under the weight of spinning matter. Mapping Earth's local gravity was just the beginning. To see the fabric of the universe actually ripple, we built LIGO, a sprawling observatory designed to catch massive gravitational shockwaves. In 2015, LIGO captured a collision between two black holes. The event was so violent it sent physical tremors through the universe, expanding and contracting the distance between LIGO's sensors by a fraction of an atom. The signal, designated GW150914, was undeniable. Statistical analysis placed the confidence level at 5 sigma, meaning an accidental noise event of this strength only occurs once every 200,000 years. General relativity explains these massive cosmic events with perfect precision. However, those same equations fail when we try to explain the microscopic world of quantum particles. To find where the rules of the universe meet, we have to look where space-time is pushed to its absolute limit, the shadow of a black hole. Take the young black hole SN 1979c. As gas falls into its gravity well, atoms collide at escalating speeds, heating to 100 million Kelvin and emitting X-rays detected by the Chandra Observatory. The event horizon, or Schwarzschild radius, marks the point of no return. For a black hole like SN 1979c, this absolute boundary spans a mere 24 kilometers. The X-ray emitting gas orbits just outside at 72 kilometers. This narrow region represents the extreme edge of observable physics, the final boundary before matter disappears from the known universe. At this extreme threshold, the standard rules governing cause and effect begin to unravel. Under relativity, events travel along a world line. A cause must physically precede its effect across a time-like interval. The outer edge of this cone represents the speed of light, the absolute speed limit. Anything traveling faster exits the bounds of causality. Quantum mechanics ignores this limit. Through a process called entanglement, two particles can become inextricably linked, sharing properties regardless of the distance between them. When an entangled particle is measured, its partner reacts instantly, even if it is on the other side of the galaxy. Relativity classifies this instantaneous communication as a forbidden space-like interval. It is a mathematical impossibility under Einstein's laws of gravity. We are left with a paradox. The rules governing massive black holes explicitly forbid the behavior we observe in quantum particles. In 2013, Leonard Susskind and Juan Maldacena proposed a theoretical bridge to resolve this conflict. They called it the ER equals EPR conjecture. The ER side represents Einstein-Rosen bridges, the theoretical wormholes formed when gravity bends space into a tunnel. The EPR side represents the instantaneous links of quantum entanglement. The conjecture proposes that these are the exact same physical mechanism. Entanglement is not a link across space, but a geometric shortcut through it. If the math holds, every pair of entangled quantum particles is connected by a microscopic wormhole. This unification suggests that the empty void we see is an illusion. If quantum particles are linked by wormholes, then the massive ripples measured by LIGO and the bizarre links of entanglement are different manifestations of the same geometry. The mathematics of black hole event horizons provide the underlying framework for all physical reality. In this framework, space is a continuously woven fabric of quantum wormholes, tying everything in the universe together.